Okay, this problem is kind of a toughie, but we'll work through it. It's in theory, it's not any more difficult. There's just it's more involved, and so it involves a little bit more work. So the first thing we do is, again, as usual, is we get the derivative of both sides with respect to x. And so you have to remember the derivative of arctangent. The derivative of arctangent is 1 over 1 plus x squared. Now here the argument is x squared y, so we'll have to use the chain rule. So we'll have 1 over 1 plus, instead of x squared, it'll be x squared y squared times the derivative of the inside. But here on the inside we have to use the product rule. So when we do the product rule, remember what we have is the derivative of the first, which is 2x times the second, leaving it alone, plus the first, leaving it alone, times the derivative of the second. Well, that's just y prime. Okay. So that's the left side. Now here on the right side, notice that we have a chain rule situation as well. So the same thing, we're going to get the derivative of the first, which is 1, times the second, which is y squared, leaving it alone, plus the first, leaving it alone, times the derivative of the second. So the derivative of y squared, that's 2y times y prime. And so what we're trying to solve for here is y prime, and so we've got to clean this up a little bit. So if we distribute this denominator onto both of these terms, we're going to have 2xy over 1 plus x squared y all squared, plus x squared y prime over 1 plus x squared y all squared. And this is equal to y squared plus 2xy y prime. Now let me mark this one in red so I don't lose it. And so the red y primes, these are the ones that I want to solve for. And so I need to bring all of the y primes to one side. So how about if we move this guy over to the right side? So we'll subtract it from both sides. Minus 2xy over 1 plus x squared y, quantity squared. And then we're also going to subtract this term, which has a y prime on it as well, to the left side. Minus 2xy y prime. Okay, so if we do that, what we're going to end up with is x squared y prime over 1 plus x squared y, quantity squared, minus 2xy y prime equals to y squared minus 2xy over 1 plus x squared y, quantity squared. Okay, now here I'm trying to solve for y prime, and so I can factor it out, and I would be left with x squared over 1 plus x squared y squared minus 2xy. And the right side is going to stay the same. Okay, and then the last step, well, that's just to divide both sides by this entire thing inside the parentheses. So this would be divided by x squared over 1 plus x squared y, quantity squared, minus 2xy on the left, and the same thing on the right. Okay, and this you can simplify. If you do all of the algebra, what you should get as your answer is, if you simplify this, you'll get y squared plus x to the fourth, y to the fourth, minus 2xy over x squared minus 2xy minus 2x to the fifth, y to the third. And this would be your answer. So that was kind of a long one. Okay, so we're trying to find the slope of the tangent line to x squared plus y squared equals to 1. And so basically what we do, since we're trying to find the slope of the tangent line, well, that's the same thing as finding the derivative at this point. So we'll get the derivative of both sides, and now we already did this in the very first problem. So I'll go through it a little bit faster this time. The derivative of this guy was just 2x plus 2y times y prime is equal to 0. And when we solved for y prime, we got y prime equals negative x over y. And so then all we have to do is plug in our point. This is our x value, this is our y value. And so here we get that the derivative at 0, or the slope of the tangent line at 0, is equal to 0. And well, this makes complete sense, because if you draw a picture of the circle, the point 0, 1, that's right here, and the slope of the tangent line is horizontal, which has a slope of 0. And so that's it.